All right, good morning, everyone. So we'll go ahead and get started. There may be a few more people that wander in. My name is Doug Phils. This is Adam Shepard. Thank you very much for coming to our session here today. The session is about schema.org, which is kind of a generic term that we often use, probably inappropriately, right, when we're really talking about structured data on the web. But schema.org and JSON LD are kind of the popular vocabularies and coding mechanisms that we use for that. I want to draw your attention to a flyer, which I hope might be in the center. So there's a lot of schema.org going on today and some other sessions taking place this week. Following this afternoon, there'll be a session on geospatial and temporal encoding in JSON LD. After that, there's going to be a session with Matt and Dave, and Chuck's involved in the spatial and temporal encoding. Matt and Dave are going to be talking about data one, and also kind of a more pattern overview of schema.org. So a flow of how it can be encoded and used for type data set, used in harvesting, and indexing and things like that. So some really wonderful sessions there. Session tomorrow on ontology work, ontology engineering, and then Andrea has conceptual modeling along with who's co-convening that? Nick Weber, thank you. So anyways, there's a lot of interesting talks taking place at ESIP, and I encourage you to go to all of them. So in this particular talk, we're gonna really kind of dive into a particular area that's of interest to Adam and I, and that is how to encode data services for discovery in a manner that we've been doing with data set. And so I want to give a little background, a little context to what we're dealing with. So we've been involved with some EarthCube projects called Project 418 and its follow-on Project 419. And I guarantee you there will not be a 420. Yeah. And part of that work was to engage with several NSF data facilities and to try and prototype out the pattern of publishing information about type data set at their websites and developing some software and some tools to harvest that information and create a index of that, and to see how we could then utilize that index for some basic services. So it was really kind of a full stack sprint, right? It was going from what do we need in terms of vocabularies, what do we have that's available to us, and what do we have that we can utilize, and then what software can we generate that would let us test out the encoding. So we created some software like Gleaner and all these kind of things that allow us to do that harvesting and create those indexes and create those services. And that was really good. It was a really fun experiment, and I think we learned a lot from that. And it was really just a great experience for Adam and I. And we appreciated all the help and support we got from ESIP and from EarthCube and from the publishers in that regard. One of the things that was interesting, though, that came out of that was that many data facilities looked at us and said, well, we don't really have the concept of a data set. Groups like Iris and others who don't make these kind of serialized products that can be represented by a landing page and can be appropriately described by type data set. We have services that describe those things. And so we really wanted to try and figure out how can we work with them to encode that information in such a way that it can be part of that kind of a semantic network, right? That can aid search, that can aid discovery, that can aid access, things like that. And so the problem statement then that came to be that we utilized for this presentation then was, how do we go about encoding type data or these services such that we can represent them in schema.org properly, right, without reinventing service descriptors? And how can we get them in as part of that harvesting and discovery workflow? And so I just wanted to set up really kind of a couple perspectives that we wanted to use for the course of this discussion, right? And we don't want to spend a lot of time just presenting to you. We really want to try and present some problems and some goals and start to get feedback from you in this group on how we can approach this. But one of the things we thought would be good was to just present a little perspective on how we might approach this. And one of them is that in some ways we have two issues that we're talking about, right? We're trying to address how can we agree on a mechanism for encoding these services, right? What are the types we're going to use? What are the properties we're going to use? We have a lot of other vocabularies at our disposal, things like DCAT, things like Hydra, things like this that might come into play in an environment like that. And what would the data facilities need to do in terms of publishing, right? Publishing in such a way that those resources then get indexed into either a index of data sets or an index that is of type data set and perhaps data services and other types, but yet we can still use them as part of a continuous semantic network. And so one of the goals then that I think that Adam and I kind of have trying to come out of this is what is a minimum viable product, where that product is really kind of a set of guidance and patterns that can be used to encode APIs and that publishers, data facilities can use to publish their information about that. And so when we have these two distinct elements, the encoding patterns and the publishing patterns that we want to talk about today. And so in this work, then Adam's been the lead on the vocabulary aspect of what we've done in 418. So Adam, can I turn it over to you then to talk about the encoding?
Hi, friends. It's great to see so many people here. So yeah, I just want to contextualize what Doug and myself, what the goal is. And the goal is really to take the discussion out of here today, because it's not obvious how to describe a data API well from the core schema.org documentation, but there's been some papers written about how to do this. There's been some folks of you in the audience who have already implemented this, like the Giovanni over at NASA with Doug Newman and Mark Reese here. And then Doug and I have played around with it a little bit for some other projects. And so what we want to do is sort of present to you kind of what's been out there right now, and then really open it up to have a discussion about how to encode it and how to publish. And so the reason that we want to do that and sort of catalyze this conversation is that we want to take this work and bring those guidance into this science on schema.org GitHub repo, where we have all these guidance documentation for our community on how to publish schema.org for the geosciences. And so the end goal is really to further those guidance documents to describe how to do this for APIs. And so today with the encoding pattern, I thought we would just start with what we did in the past for just describing a data set in schema.org. And so we've got some very small discrete examples. Can everyone kind of see that, or do we need to, how do we go into presentation mode here? Is that better? Okay, so really quickly, if you're just trying to describe how to get at a static file for a data set described at schema.org, and obviously there's a lot more properties that go in here. You have a type data set, there's a distribution property that points to a data download, and that data download should have a content URL, and that URL is how you download that data file. And so for a static file, like a CSV file, this might be the URL that you put in that data download, and that's great. Now, as a sort of a next iteration there, that there could be a web service that serializes that same CSV file, and that might not necessarily be a static file on some web server or in an object store, but it could be an API that takes like a format and a data set identifier. And here in this content URL, we've hard coded that format and the ID in the data download. And that might be another way to represent that, but that might not necessarily work for everyone. And so another iteration, which is really crazy, and we're getting down into the rabbit hole here, is to, for that data set, describe a potential action, which is a concept in schema.org for describing how a machine might actuate a service, to describe how to tell a service endpoint what format you want and what data set identifier you want in this case. And so I don't know how we can get these. Does everyone have the Google Doc bit.ly link? Okay, so you can find all these links in there and the JSON LD examples, and we're more than happy to iterate and talk and pull up some tools right here and talk through this. So I guess I just wanted to show that these examples just to start the conversation about how to embed, and then just open it up to you guys. What are your thoughts? What are your ideas? Who has played with or tried to describe APIs, or what are the common issues that you're having with doing this type of thing in schema.org? So anyone want to start? Yeah, okay, great.
Not as a repository person, but as someone who contributes to a repository and then goes to search for items which schema.org picks up because our repository does put this indexing at the top of them. I noticed it's only allowing one identifier, and there's the identifier when it goes into the repository, and we have time series that revise, and I'm noticing duplicates. So I don't know where this fits in the schema.
Yeah.
But that's a very important concept for us. The concept of one revision obsoletes the previous revision.
Oh yes, okay. I don't know if that's in the scope of the APIs, but we could certainly talk more about that after in another session, maybe, if that's cool with you.
Yeah. I think also it'd be good if you have things like that, the issues aspect of the Science on Schema GitHub repository would be a wonderful place to put things like that for us to review and things like that.
I don't think the document you're showing on the screen here has been shared, or it's not from the shed or the sched anyway. They've got a bit.ly up here, folks.
Yeah. Is that, sorry,
Thanks.
no.
We couldn't find the link, Lewis, that we were supposed to use, so we just made one up.
I think that's an O, is that right?
Oh.
Thanks, Lewis, appreciate it. Yeah.
So there's one thing I would like here. Can I jump in here real quick?
Yeah, go for it.
So just provide a little bit more context to this, and then Alistair, I may call on you. Did you get the bit.ly? Okay. That's okay. I can talk. So we're talking about the encoding aspects, but one of the other things that's intriguing to me is how we may have to approach this from a publishing point of view, right? One of the things that could potentially happen is that a data facility could look at their holdings that are mediated by a service and say that there are citable units that we could create out of those service APIs, right? And so they could essentially create virtual data sets by prepopulating service calls and making landing pages for those. Those would really, in essence, be of type data set, right? Because they would be a set of data resolved by a referenceable URL, right? And you could add that as a potential action, right? You could add that URL could have a potential action for it. One of the things that I'm trying to address is the fact that if you go on to Google Dataset Search right now, right, you will find a lot of APIs. And in fact, you will find a lot of tutorials about APIs. And so you can do searches, and I've linked in a couple in this document. You can do searches that do not return data sets, even though they are typed as data sets, right? And this is because people want to get inside Google Dataset Search, right? So they'll sit there and go like, here's my API, it's a typed data set, and I'm going to describe it so that it gets discovered, right? What we're really trying to do, though, is say, can we approach that a little bit more systematically as a community, right? Can we actually describe these things, one, as proper types, and with the proper properties to those types, and then maybe expand what we kind of view as the corpus of the semantic network to get at something like that. And so these are some of the publishing patterns that the data facilities might use in that regards. So one of the things that I was intrigued about, and Alistair, I don't know if I could call on you to talk a little bit about Selfie, just real quick, just to introduce it. But I was really intrigued with the way Selfie's looking at encoding both APIs, but also then the links that you use. Can I call on you to say a few words? Oh yeah, then come up here. How many words you got? Are they good, kind words? All right.
I love giving presentations with, what was it, 45 minutes? 45 minutes notice. He comes up to me and says, how's your presentation going? And I laughed. It wasn't a joke. how do I get rid of later? Let's try that later. So I'm Alistair Ritchie. I'm from a research institute in New Zealand, which explains the accent. And I'm currently co-leading one of a series of interoperability experiments that the OGC is doing on basically this problem. And with Dave Blodgett is the lead. I'm not sure if he's in the room here, but I'm doing this on his behalf. So what I'm giving you is a presentation I gave to the OGC a year ago, roughly, about, I'm doing my worst thing. How do I switch? Go into presentation mode. Open it with PowerPoint. Yeah. Cool, thanks. Board. Let's try Google Slides.
Yeah, there we go. And then there's like a present button, I think.
So, no, cool. Right. Roughly speaking, I mean, Alfie came out of a discussion that was had after an interoperability experiment about soil data, which was largely, hey, look, we've got a heap of distributed data here. We keep building these standards for them, but nobody actually uses them and nobody can find our data. So we wanted to look at a way of actually flipping things around and make data more accessible using widely used web technology, but also make it indexable. So there's a variety of participants you don't care about. Part of the problem statement we're looking at is we're focusing this on environmental features at the moment, and I work with soil scientists, so part of our issue is soil is a function of most of the rest of the environment, therefore we have to be able to integrate data from most of the rest of the environment. But we're also dealing with widely distributed data sets. For a given description of a resource, there's often many different, they often reside in many different repositories. And then there's also this bit about the fact that, you know, we can't just keep this for scientists and specialists, we actually have to make it usable for the mass market. And we know that the building blocks exist, and you guys are aware of these as well. We have JSON-LD available as encoding, which is already very friendly. We have schema.org, which is already very successful. And then we have the linked data and the semantic web that give us more advanced tooling. And then alongside that, the OGC and the W3C have done a tremendous amount of work in coming up with good, robust ontologies that we can use to describe the environment. And another nice thing, another nice piece of work that happened was the OGC W3C collaboration, which was to generate the spatial data on the web best practices, which had a similar intent about actually making sure things were nicely identifiable, linked together, exposed with convenience APIs, and perhaps most importantly in this context, indexable by search engines. Flying through that. So great, we want to do stuff for the mass market, but we don't want to throw away the discipline that comes with actually working in standardization projects, right? We don't want the Wild West of, you know, what does this key mean? It says pH, but is it the same pH that others are providing, and so on. So JSON-LD is great for that. Because I'm guessing, as you guys know, you can bind your JSON keys onto entries and ontologies and make things nice and unambiguous. So we came up, so as part of the first Alfie, we came up with a set of contexts that bound onto our existing information models and improved that we could quickly and easily generate JSON-LD documents that could be used by for visualization purposes, analysis, and that kind of thing. And it was quite successful. We've now started Selfie, which came from second Alfie. So I groan so that you don't have to. It was one of those things that it was presented as a joke by a Canadian that we're no longer friends with. And the OGC just loved it, and they jumped on it and became the official name. And as I've said to a few people before, I think the fact that this is a popular name in the OGC is desperate proof it needs a girlfriend. But what we did here is we started looking at the problem of the distributed graph. In traditional linked data, you dereference your URI for a thing. It's held in a single the data held in a single triple store. You can send a request to that, get back the whole graph. That's not how it works for us. You've actually got statements scattered across the web. So we're looking at this issue of how you how you sort of go from your non-information resource, your identifier for the real world thing, and actually get to the many digital representations that are out there. So what we're experimenting at the moment with is this thing we're calling a meta resource, which is a convenience thing that sits in the middle, so that when you dereference a URI, you get a set. You want to change on me? Yep. You get a document. Apologies, that's not really readable, which is sort of a starting point. It's annotated with schema.org properties to help the indexing of this real world thing, and then it has hooks into the digital representations, and we're loading those up with information about what type of thing it is according to an ontology, what formats are available, what formats are available. It's available in if you do content negotiation on the request, who provides it, and that kind of thing. The idea being is we've got quite a large graph here, and any agent that's discovered this thing doesn't want to hit every single link to find out whether or not the data it wants is actually at the other end of it. So we're preloading stuff up to help with efficient traversal of the data. And I think that's it. So yeah, we've got, this is hot off the press, the laptop from a meeting in Quebec last week with Natural Resources Canada, and now we're about to start actually testing it in the real world. And the exciting thing about talking with Doug and Adam last night, very cool, standing in a hotel bar with laptops out, drinking wine. It's how interoperability should be done. Is I think that this group can actually join Selfie, join Selfie, and help us tighten up a lot of what we're doing. Yeah, thanks.
Yeah, you can apply for that. So, and there's a lot of other work going on too, right? You know, the drone APIs and things like that are taking place. I think one of the things we'd like to try and get to here at this point is really just kind of start getting some feedback from this group, because there's a couple things that we're kind of interested in, right? We're really interested in, you know, what are the expectations that data providers, data publishers have in terms of how they can represent information that's mediated by services. I'd also be really intrigued for a researcher's perspective on finding data that's inside these types of services as well. So, you know, if there's some comments, some ideas I hear, I'd really like to get this group engaged.
First of all, raise your hand if you have an API at your.
Yeah, there you go.
Okay, and how many of you folks that have APIs want to describe them with schema.org? Okay.
How many?
No pressure or anything.
How many are doing that now? So how are you doing it? See how you put them on the spot?
Yeah, that's right.
So
Yeah, maybe, yeah.
Okay. Is that what you're going to talk about, Lewis? Or
no, I was just going to mention from the scienceandschema.org work that we've been doing, or you know, that's available at the PODAC. We've described data sets and data repository.
Mhm.
One of the ways that we're linking into the access service is I think what has been implemented over at the NASA's Earth data is just using search action and data download, where we just populate parameters in, which are customized, which are probably unique and customized to the services which are available at PODAC. One of the things I think that's missing here, though, Doug, is that it would be beneficial, I think, for the audience to see what it would be like from, and you just mentioned it, is to see what it would be like from the client accessing, you know.
Yeah, would you guys like to see an example of that?
Yeah, I mean, it's assuming that everything's right.
Too late, we're doing it, yeah.
Assuming that work has been done, what are the benefits to me implementing that at my organization? I think that's where we need to hit just now.
That's great, yeah. And I think from the Iris data repository standpoint is that they didn't have data set landing pages. And so they really struggled with like, okay, how do we get in this Google data set search game? Not that that's the only reason or the game in town, but like, how do we get our data indexed? Because they don't have these landing pages. And so I think for them, that was a driver. And so if you folks have other drivers, like you don't have landing pages for specific data sets, we want to know about that. So let's just quickly take a look at what the NASA Giovanni project did. And I'll bring their slides right over. Cool.
Yeah. All right, so my name is Mark. I'm the product owner for Earth Data Search Client. So we have implemented, to some degree, smart handoffs with NASA's Giovanni tool. Let me read this real quick. Talking and reading is not a strong suit of mine. We have a full deck. I guess we weren't quite aware that this was changing to a workshop, so I'm going to kind of fly through some of these slides so that we can continue discussion. But I did want to show from an end user standpoint, what we call a smart handoff would look like. So in some cases, a data set or a collection, as how we refer to them, has services that can be applied to that data, but only by a very specific tool. We don't support the customization or the visualizations within Earth Data Search, but there's some other tool that does. So we want to provide a way for a user to transfer their context, the collection that they are interested in, their spatial constraints, their temporal constraints, maybe even their variable, if they're only interested in a particular variable parameter, and then take that to another tool without having to re-enter all of that search criteria. So again, we call that smart handoffs. Check the resolution here. Not every single collection will support this. We have some. Let me get one pulled up. There, this is backwards from mine. That one. Any cyclists in here? Any road cyclists? Yeah, a couple. Tour de France is going on. It's a big month for me, so I'm going to search for some data over France, because why not? And they come back. And I happen to know that this collection has smart handoffs enabled. So again, we have a sorry about that resolution. We have spatial constraints, France. We have a collection, this AMSR collection. I'm going to provide a temporal, some temporal parameters as well. And so we have the three things that we need. And I'll double back on something we're going to add in the future as well. So instead of downloading that data, I want to visualize that in Giovanni. So we have a kind of tertiary actions icon. If you're familiar with any sort of Google app, they have that little 3 dots. So a user would see that. We provide this same kind of jumping off point at various places throughout Earth Data Search. But you can open this collection with Giovanni. So a new tab opens up. The users, again, the spatial constraints are represented here. I can toggle back and forth. So you see, whoa, hold up. This 50.3498 is somewhere down here. This 50.3497, round up, whatever. So all of those parameters are taken from our URL and mapped over to the Giovanni URL. Again, you don't have to do anything except for the visualization piece, the piece that Giovanni specializes in. So the way that we do that, yeah, so the way that we're doing it right now is we're just placing tags onto a collection within the CMAR, the collection metadata. In the future, the way that we would like to do that is have a UMMS, Unified Metadata Model Services record that describes various services about a collection. We would like to add a description of the API or these services that would enable us to more easily get this information about various tools. It's kind of very manual right now, but we want to add that to UMMS records. So we are using search actions, and we've basically just mapped the various parameters from our URL to Giovanni's URL, and it's represented like this. Let me get presenter mode here. Come on, here we go. Oh man, that's terrible. There actually is a highlight. Oh no, look at this. I'm presenting someone else's slides too, if you can't tell. I did work on my Scottish accents, but since Lewis is in here, I just can't. Yeah, so we have a temporal constraint defined and a spatial constraint defined. So again, we have that URL template for the API or the service. We just plug in those values and then transfer the user. Yes, yes, we are. Yeah, so the only tool that we support right now is Giovanni. Next up is State of the Ocean. So we've not ran into that scenario yet. Some of the challenges that we do face right now, specifically as we start to branch out to other tools, is various tools are going to reference their holdings in different ways. So Earth Data Search, we interact with the CMR, the Common Metadata Repository, as like with collection IDs. It's a unique identifier. We can speak in collection short name, which that's how Giovanni speaks to identifies collections. State of the Ocean does it a different way. They have their own names for collections. So that's a challenge that we're going to have to tackle fairly quickly. I think the idea right now is to have some sort of alias where we can map these things across. But that's certainly a challenge that we face on the horizon.
Can I just add one cool thing about what they've done here? So
yeah.
The really cool thing about describing this API in schema.org, as opposed to just in your code, oh yeah, I know that the user put in this, geo shape and this, and I'm just gonna rewrite this URL and do that. That locks those tools together so that no other tools outside of that space can use that API. But because they've described Giovanni with schema.org, anyone can harvest that schema.org and write their own call-ins to Giovanni. So, me at Bicodemo or wherever can say, oh, I want to, someone just messed around with my map and my temporal ranges on my site. Let me shoot those over to Giovanni through this search action call and give my users at Bicodemo an opportunity to see what can be visualized at Giovanni. And so by using schema.org, they've opened the landscape to anyone querying that API in an actionable way. So it's not just locked into NASA tools and their developers.
That's a great question that I don't have the answer to. I might be able to find it real quick. It would be listed in here. Yeah, the type service.
Are you trying to get, are those getting indexed by Google? Or have you exposed them with a sitemap or anything?
I don't have the answer to that question. I can certainly dig it up though. Lewis has a question back here.
Thank you. So one of the issues that we've been constantly getting here and have been discussed within the NASA meetings was when do we know once this stuff's picked up? The main way you're going to know that is by monitoring, for example, a results ranking from Google or somewhere else. Or you could look at the Search Console. Well, yeah. Assuming that the Search Console stuff has been done, right? That you're making sure that, what they're expecting to pick up is done. You Search Console out the side, done and dusted. But then that, just because it's in the Search Console doesn't mean that it's going to go right into the rankings, right? Search Console and result engine rankings are two different subsystems within Google, okay? So the main way that we actually find out this having an impact is by looking at the results ranking. So one of the things we're doing at PODAC, and it's very, very, very arbitrary, very simple. It's just a simple, nightly snapshot. We're taking a snapshot of the page and we're posting it to the data engineering team to see if the stuff that we've marked up is coming up, in particular, at whether our search actions are being interpreted such that from within a Google search engine result ranking, not only that we're up, top for a data set, but the search action is embedded within that result engine ranking, and you can search directly to the service which you've described from the Google entry, right? That code's going to be open when we're open sourcing that code across NASA and whatever, anybody. So I've seen some differences actually where in the data repository markup, So if you go to podac.jpl.nas.gov and look at the source, you'll see that we've marked up for type data repository. And we've linked into like Caltech, we've linked into NASA as a parent, as a sponsor. EOS, this is a sponsor to PODAC, and we've made these linkages. And now what you'll see is we have a rich text snippet, which appears with a whole bunch of information, social media links and all this kind of stuff. Whereas, maybe 3 or so months ago that wasn't the case. And what we're doing now is, as I said, it's very kind of primitive, but at least it enables us at every opportunity to say, well, 3 months ago, here was the snapshot, this is exactly what it looked like. And then today, 3 months later, it's totally different. I think that's been done from across NASA as well, or in LDAC, I think had maybe done something similar with Dane Wright. But there's some primitive tooling for us, for you rolling that out maybe at wherever else, and the same type of stuff around here, folks.
So, but you are seeing.
We're seeing a difference.
You're
no
seeing
doubt about
services that you've marked up with the structured data.
So not services right now. Okay. So that was for data repository.
Okay.
So essentially what we're doing is we're embedding
potential action with the repository.
Yeah, potential action, but also with data sets. Okay. So the parameters we're piping into search action are very specific for that data set as well. Okay. So we've got a handoff to off data search client and things like this.
Thanks, Lewis. I saw some other hands of people that were publishing services. Simon, did you want to say something? Or?
I just wanted to, I guess, raise a clarification about what the goals are here, because we've just gone into essentially, ranking in Google.
Right.
And before, Adam was focusing more on service endpoint descriptions to allow more automated sort of service chain construction. Mm-hmm. And, are these going to be solved? These are not the same goal.
Here today? No.
They're not going to be solved here today, but we should be aware that there's a couple of things going on here, right. And what's the right source for one is not necessarily going to be the optimum source for the other.
Right. I mean, bluntly, more I think our goal for today was really kind of what we tried to present at the beginning, right? Is that we did this experiment with type data set, and it was easy, right? I mean, really, the facilities have a data set. It has something that can be downloaded, and we can describe it. But then we ran into this issue where facilities are like, we have services, right? And so we don't have the concept of a data set, but yet we'd like to be part of that search, right? We'd like to be part of that. And you can either game that type by saying, here's virtual data sets, right? The pre-populated service actions, and then those are potential actions that we might be able to branch out from. I mean, I don't want to game it by doing what some people are doing, right? Which is saying, this is a data set, but it's not. Go ahead, Simon.
Yeah, and I mean, I've done a lot of work in the last couple of years on a W3C project aimed at upgrading DCAT,
right.
And actually, which isn't so well known around here, but actually has exactly the same goals as that bit of schema.org. In fact, it was the template which schema.org's dataset descriptions was built on, was right. The original DCAT. And one of the main requirements in the upgrade of DCAT, which is used in Europe a fair bit, was service description. Right. And so that's actually there now in the almost candidate recommendation.
Right.
From W3C. Now, that doesn't mean it's been widely implemented or used, but there's some patterns there, and it did involve introducing, a new type.
Right.
And some very, very explicit relationships between the things of type data service and things of type data set.
And was data service a subclass of data set?
No,
it wasn't.
They're both subclasses of a superclass.
Right. So they're both parallel to each other, right? Yeah. And so, I mean, and this is the thing. And Steve, I don't know, you had a couple of slides. I don't know if you want to talk about that now or just say a few words. But I mean, this is kind of the thing we're running into, right? Is that people are gaming Google Dataset Search right now, right? To get APIs into that environment. Maybe that's fine, right? Maybe it's like shoehorning, gaming, whatever. And maybe as a community, we're fine with that. I don't know. But me personally, I'd like to make sure they're distinct types so that I can treat them different and move with them in different areas. Did you have a comment? Yeah, go ahead.
Yeah, Emilio Mayorga. I don't know how this could tie into schema.org, but all this discussion reminded me of some community efforts that Steve commented on GitHub at the CAT from OSG or CAT Interop that put together what started out as a CSV, but a very well-structured CSV of data set and service types that was well-defined. And I believe there were some efforts to develop automated translation from that simple CSV into linked data friendly forms. And it became pretty extensive. It may have stalled a bit, but that CSV is pretty rich. It's hard to imagine that it could be richer. I wonder if that's something that's been looked at in the context of schema.org. I think it arose out of ISO 19115 kind of link type descriptors, but it was built in a fairly generic way, and it encompassed things like OpenDAP. I mean, all kinds of services that I could think of.
Right. But would that be, Steve, do you want to comment on that at all? Or?
It was started in OSGeo. Tom Krolitis, the guy who developed PyCSW, really set it off basically because, you know, in the catalog services, there are all these fields in ISO metadata that didn't have associated controlled vocabularies, and they wanted some way to have a systematic way to identify service types and right. Application profiles. And so that's what grew out of it. And a number of people have contributed stuff in there. It's in GitHub. There's, I guess,
okay. There were a couple of people.
Links around everywhere.
Okay. Thanks, Steve. There were a couple of people I think who raised their hands saying that they were publishing their services through schema.org. Was there some other people who wanted to talk about anything that they were doing with regards to publishing services via schema.org? Okay, so I mean, that's fine. So we return to this point though, that at some level, we want to be able to describe these APIs in such a way that we can index them and rank them. And I mean, and maybe it's a situation where we just have to accept that they're different types, right? There's type data set, there's type data service, right? But if there's any like data facilities in the house that are exposing their data primarily through APIs, I'd be curious of any thoughts or patterns that you've had in terms of trying to approach getting yourself into the Google dataset search environment. And not that that's the end all be all, right? Google's not the final target, right? Groups like Data One are looking at this kind of stuff, EarthCube, you know, anyone can build an index from these types of things. But I mean, it's just the one that we typically always talk about. But are there any providers who'd like to talk about challenges, desires they have in terms of trying to publish their service mediated holdings into these types of environments?
Did you ask Natasha about this? Because in June, Google released something called data feed for schema.org.
Right.
And it's got these, you know, action options in there. And I just asked John Erickson, who's one of the originators here, and he said that data feed was considered to be, at the time when they did data set, was considered to be a subtype
right.
of data set. But they never worked on it. They never touched it. They never picked it up. And it looks like it's been worked on only by Google. That's the intel I just got back. But I'm going to paste an article from SEO Skeptic that might be worth people taking a look at.
Great. So Chuck had a comment here. But the types under data feed, would they? I mean, eventually you get down to thing, I suppose, with data feed, and you could describe anything within a data feed. But
yeah, just a related comment on this general semantics of action, right? Mm-hmm. And so just a quick Google search here right now, I see in the Google Assistant SDK, schema.org query pattern types. So it's not just the web interface search query, right? It's this general idea of there's a super type of actions, right? So these are affordances that smart agents like Google Assistant, like Alexa, can then perform on data types, right? And so by structuring data in this way, it not only enables agents such as, you know, the Google search agent, whatever that is behind the scenes, but also enables other sorts of smart agents to be able to perform actions which help end users to search things. And for example, right, I can imagine smart agents that are plugins to R and to Jupyter notebooks right now that help you basically dynamically connect the data sets, bring them in. And there's people already developing these things, right? And so there is the sort of first level action which we have today, which is essentially connecting, finding data sets through the Google search. And then we also have the future, right, which hopefully will bring smarter agents that can help scientists in a more natural way to find these data sets, right? And that's the idea behind this action thing, is that it gives that key to agents of the type of affordances, whether they're search affordances, right, whether they are, you know, what the API is in order to facilitate the transfer of the data, and then what the meaning behind the data actually is, right? And so those are sort of the things that I think we want to sort of keep in mind that when we're talking about these things, right, that these are evolving things, but that the ultimate vision, right, is smart agents, right? And that's something we want to enable, even though we sort of giggle when we say that, right?
Well, no, I mean, I understand, but and Adrian, I just want to say one thing real quick, if I could, before that. But one of the things I'd just like to throw out to this group, and then Adrian has a conceptual model that they'd like to show that I think is relevant to what we're talking about here. But you know, from a practical standpoint, right, a selfish standpoint, when I step here so I want to throw this out just for people to think about, and then maybe after this, if people want to comment on it or feedback to me. But when we're, you know, actually talking with the CDF members, and we're actually saying, hey, look, this is how you're going to publish your resources, and this is how we're going to index them, and this is how we're going to provide search actions on them. If I go to Tim Ahern at Iris and say, okay, look, you have no data sets, so tough luck. You're not in the data set type, right? You can describe your services, and we can provide a search mechanism into that semantic network that might return services. And we'll essentially almost have, at a user experience level, a UI level, separate those types, right? Because we can't relevancy rank between services and, you know, type data service and type data set. And that may be what I go back to the EarthCube, you know, advisory team that's been monitoring, and say, we're not going to do that. Actually, it just isn't right. So I'm just throwing that out as a concept, as a question. And you want to comment on it, or go ahead? Adrian says go ahead and comment on it real quick.
I just wanted to comment about having done some experiments with the search actions that there's quite a bit of fuzziness in the documentation for how you actually express the input and output parameters on the search actions. And so I think, you know, in terms of actually getting something interoperable, it's those nuts and bolts that have to be worked out. And we're not going to do it here.
No.
But I invite, you know, people to try and experiment with how you actually link input operations and requests with the input format and content, and what the output is going to look like from the search actions. Because really, if you want to start automating stuff, that's what you have to be able to do. And I think right now in the documentation that's available for that, it's a little unclear. I think the other thing I'd like to mention about this question of services is, it seems to me that there's this kind of this data feed idea is important in the question of what we mean by data services. I mean, from my point of view, working with this stuff, scientists come in and they're looking for data. They don't come in looking for services.
Right.
And so they want to know first to find the data, and then how do I get it? And maybe they get it through a download, and maybe they get it through a service. And that distribution pattern that Adam showed works really well for that. But the problematic things are things like real-time feeds from Chords, things that come from Iris. And that's a situation where I think the data feed probably makes the most sense to describe something that's sort of a continuously evolving data feed, and you have some kind of service request that you set up against that, where you define what information from that feed you're interested in and the time frame you're interested in over. And that can be built into these search actions very well, I think, and still be indexed. The rest of the content is like a data set. Seems like it indexed just fine.
Right.
Anyway.
Peter? Oh, I'm sorry, yeah. Oh, thank you.
So, and you've got a hybrid too, because think of dynamic data citation relies on the ability basically to execute a query. And that's going to come from a URI, most likely, that sort of normally looks like a data set, but it's not a data set, it's really a data service.
Right.
So I think the fundamental need that we experienced with IRIS when we became aware of the schema.org effort was that there was so much of our data set that was not represented in that because of the service issue. And so what occurred to me, what was most important both to us at management level and to our funders is really first and foremost exposing as much of our data sets as possible that satisfies a more political sort of need, to get that out of the way first, and then to be able to express in a more rich way how to do these handoffs that we're talking about now. So with regards to services versus data sets, I think what we might be able to do is kind of what you had alluded to, is that we focus instead on making the data searchable and then describe services that allow access to it. Sometimes it is just a single download URL endpoint, but it also could be a number of other services that do filters or transformations or whatnot. If those could be expressed as a subtext of that data set, then what I think we would probably do for our continuous data streams, I mean they're quite enormous, is we would break the data sets down into the sources of data, which are seismic networks. And so we would look for the right level of cardinality so that we don't have 500,000 entries going in dataset.org, but a meaningful, 200, 300 or so entries that breaks down to the networks, to the sources. And then that connects to everything else, which is the publisher, the funder, the point of contact, that sort of thing. It's the most, I think, the best level of, locus for this sort of discovery.
And my apologies, you're right. I wouldn't report back to Tim, but Tim's on the advisory group within EarthCube for the work that we're doing. So it's like, yeah. Adrian, so.
So I just wanted to share no answers here, just wanted to share some work that we've been doing in Australia, and there's a whole set of links that come off this slide, and I've put them onto into the Google Doc. I do agree with, I think, Simon and Peter and Steve around the two things we're trying to do here. One is around service orchestration, which requires the inputs and outputs and the parameters, and then the other thing about just finding out where services are, and then doing the cottage industry thing that we've always done around working with the service. So we started off with thinking that we might be able to do some work around the whole service orchestration, and then pulled it back to the first one just to say, look, could we locate the kind of services that are available across government, research, universities in Australia? And we kind of went back for it. It was not a theoretical thing. We already had a catalogue of data collections that cuts across government, universities, and research facilities in Australia. It's about 150,000 collection descriptions, and we also had some service descriptions as well. And then we had a whole lot of collection descriptions that had the distribution of the service. And so we'd done a little bit of work in the background of what we could do to sort of create proxy service records for services that were referred to in a number of collections that came from the same provider, or even from different providers. And just recalling, we were doing this from everything from astronomy through to religious studies. So it was, and that's a circle that joins up actually. And so we had statistical data and WFS and a whole set of just open API stuff. So we were trying to work out, how we could do this sort of in an agnostic way. Look, it's just some of the lessons we learned. The schema.org and the DCAT work that Simon really helped us with provided some really nice sort of lingua franca for us to map a whole set of stuff to from a number of different domains. So I'd recommend that we kind of work in that area. And then we started with the end user experience saying, if I'm a scientist and I'm just looking for something, mangrove swamps in New South Wales, and I'd like it to be a service that I could use in, with this tool. We looked at the number of properties that person would need, and we kind of came up with this little diagram that said some of them would be the properties of the service, some of them would actually be properties of the data, and that the actual query, the sort of search would have a number of those properties. And so we started off really separating them out, but then when we were doing the product, we were actually merging the two back again. Anyway, so that's some work we've done in Australia, and there's the actual real work is in the two links that are at the bottom there. We've done all sorts of mappings and that from our own work. On the schema.org, and so that catalog that we've got, there's about 1,000 service records amongst the 150,000 collection records. We've already done a mapping to, we just went ahead and did it for all those service records to schema.org/service, which also exists. And it wasn't bad. I don't know whether anyone's using that particular output. I haven't checked the sort of the Google index as to whether that's, I don't think it's being picked up in the dataset search thing there, but so anyway, we have that mapping, and that's public there as well. Yes, so this slide is in the Google Doc, and then there's the links within the slide are probably the important ones.
Yeah, I'll ask you, Adrian. But I think it's a larger question for repositories with increasing security requirements. Almost everything now has to have a certificate-based access, and we tend to sort of ignore that in our community. There's no concept of HTTPS really, but it's there, and I wonder how we have to sort of really accommodate that, or do we have to accommodate it at all, or is it going to be handled in the web infrastructure? And then secondly, no one's mentioned authentication. And it also too is a fairly big issue, because that becomes very credential specific. And there are many organizations that will absolutely make their data services available. Oh, Nathan is here. Just looking, well, because OpenDAP's been working on the schema.org for OpenDAP services, and I wanted, so can you say something about that too?
That lets me escape. That's pretty good, actually.
I had a question for you about what you were just saying, and I can't. Now you distracted me, and I can't remember what you were on about. I know. Well, and I don't really have a comment. Please refresh me. I need your help here. Where were you when I raised my hand? Because it was about what you were saying. Yeah. So crucially, I think that the point I was going to make is that the authentication case is even actually more complex, because there are going to be situations where the services that are offered to you will depend on who you are. That's all I was trying to get to. Like, it's going to be a function, like once you've authenticated, it might say, you can do these 3 things. Then you authenticate and say, but there's a whole list of stuff you can do now. So there's that.
So that's a good segue into something that I've been thinking about as this conversation evolves. And service orchestration, is obviously a very detailed, sort of in the weeds approach on how we can do machine-to-machine interoperability. And there's been a lot of work in this space in the high-performance computing community and the workflow community, building pretty detailed service orchestration languages, workflow languages. They describe input and output parameters, computational models for how you execute services into pipelines. And it feels like we're taking a very simple approach of schema.org and trying to map it onto an incredibly complex problem that has been very well explored for better than 20 years. I'm just curious, like, why we're starting down that path again. Is it just because schema.org is it's JSON-LD and it's really easy to start there, and we're just going to go down sort of basically rebuilding the infrastructure that's already in place in the workflow land?
So in terms of what you said is exactly right, but schema.org wouldn't have existed if we'd got other parts of sort of whatever we're calling it, markup and things like that. If we had got that right, we wouldn't have schema.org. So we are asking the search engine providers to do something for us, heavy lifting, right? So the same is true here. So it's always going to be absolutely fundamentally compromised. We hope it's not fundamentally flawed, is really the I think the thing that we're talking about. And so I like what Adrian presented. You know, the approaching it from a conceptually, what are the relationships? Conceptually, what are the which is in the new. I don't know if someone wants Simon to say something about the new DCAT, but it's a really nice piece of work.
I just wanted to comment on something that Peter brought up about subscriptions and authentication, and I think Nathan brought this up as well. In our digging into the action class and what can be done there, we came across an example of in the schema.org documentation about how if you were going to watch a movie on, let's say, some service, but you needed to be authenticated to watch that movie. There's some classes in schema.org, and I think media subscription is where they start, and you can sort of dig into how schema.org approach that. And they really punt off to like, okay, we're going to assume that there's some open API or what is it? Open API, what's that login? OAuth, like some OAuth that we know your subscriber name. We have no idea about how you authenticate, but we'll connect you into that service and do the handshake. So there is some work there, and I'd encourage you to check that out. And so I want to segue from there into this GitHub repo where we're doing a lot of this work. And so if you're interested in, all right, how do you do authentication on web services described in schema.org, or you're interested in talking about service orchestration or any of these topics, I encourage you to jump into this GitHub repo here in the EarthCube web space. This is sort of like the test bed for where we sort of talk about ideas. And then as we form them up as a community, they sort of graduate into the science on schema.org space where we sort of, I don't know, the ESIP community blesses them as our guidance. But this has been really an ad hoc process for us. This isn't really a formalized workflow, but this is kind of what we're doing right now. So if you guys have any thoughts on governance or just topics, please jump into these GitHub repos in these documents so that we can engage with you. So. Sure. Yeah. So in this GitHub repo, it's called P419 DCAT services, and the reason we called it DCAT services is because we thought that we knew that Simon was working on it, and we were like, oh, Simon's doing all the work. We can just plug into what he's already done. But anyway, in this repository, we have a couple of JSON records, and one of the projects that we looked at was this chords project. And I mean, these are no means, de facto standards of what we think we should do, but these are just attempts at how we would describe a data feed, how we would describe a web API, how we would describe a research project. So I encourage you to look at that stuff and comment and tell us where you think we went wrong, or give us suggestions on how you think you would do it differently. I do want to mention that one of the things that we've noticed with the schema.org community is that they'll tend to publish classes up in the pending space or on their website quickly and let the community sort of figure it out and iterate on it. And I think that's a little bit of a different paradigm than what our community's used to, where we sort of iterate on vocabularies and iterate, and then we publish. And so I think we have to remember that. Specifically with the web API class, that's been published up there, but there isn't really a lot of documentation, guidance, examples from the schema.org community on how that was intended to be used. And so I just wanted to encourage you not to be frustrated by what you see up on schema.org, but think of all these classes as an opportunity to iterate and work on improving them. So, did anyone else have comments or thoughts in this API space?
Okay, just to maybe try and get some discussion going, then let me just kind of, again, go selfish on you, right? And think about how it is that I'm going to try and take things away from this and go back to EarthCube with them, right? So when we're looking at something like trying to index the type data sets that are coming out from the various data facilities, right? It sounds like I could potentially go back and say things like, oh, well, look, we have data feed, which is a subclass of data set. Potentially, right? Google would be indexing this as a type data set if it's a subclass of it. And so we could leverage the data feed as a way to describe these services, and then perhaps bring in some of the other vocabularies like DCAT and things along those lines. Comments, concerns about whether or not that would be a good direction to go with something along those lines? Silence is blessing. Chuck, you have some comments to make. I don't know. You made a motion. That's practically like bidding. No, okay, I'm sorry. I'm not going to put him on the spot like that. So.
Yeah, I mean, I think that this is a good direction. I mean, one of the other discussion points that is, and I'm going to selfishly lead into maybe some of the discussion for this afternoon.
Sure, go ahead.
Hopefully encourage people to sort of come back, right? And so there's sort of two sorts of proposals right now in terms of organization of things. There's a science on schema.org, which I think is about data repositories, data sets, organizations, publishers, these sorts of really good things. And it's fantastic because there are a whole bunch of really good examples. So we spent some time walking through these examples with Neon and seeing, and actually they were gracious to join us during this sort of walkthrough for their data sets to see how publishing that information according to that template, that JSON-LD template that's there, whether that would work, not work. We did discover some things that worked, some things in terms of how they organize data, their landing pages that are a little bit different than just a plain data set landing page, in that they're organized spatially and temporally by observation type. So that's a little bit different, and we'll get into that this afternoon about how the second thing that might be needed is some hooks into schema.org for some missing types, right? That are subclasses of existing types in schema.org. And I think there's sort of a proposal right now of maybe calling that geoschemas, right? Much like bioschemas exist, and leveraging some of the work from bioschemas. And so those are sort of the two related, somewhat parallel tasks, but they're dependent on one another, because the extensions where we find problems in describing a data set here, those naturally lead themselves into things that probably should be in something like geoschemas, that then provide hooks then to lift into more expressive vocabularies and ontologies, right? Much like bioschemas does. So that's a little preview, I guess, of this afternoon, in case you were curious. So that's my comment, since I was put on the spot.
I didn't mean to do that to you. So.
Oh yes, you did.
I did. Absolutely. I think I'd like to throw out maybe one more question in this, and part of it is just to kind of express some of my ignorance on how this might take place for various data facilities. And one of that is that when I look at this and I look at things like RESTful type services, it's fairly obvious how to approach that, just because I work with those types of services a little bit more. I'm curious though, people that are working with more OGC type services would see some red flags or issues with trying to look at describing these types of things using some of the types and properties that are available to us within schema.org or in DCAT. Do you not see any issues, Simon?
I don't think so,
okay.
Because the fundamental, right there at the top of schema.org and DCAT was the separation of the file and the data set, and the descriptions of those are separated. Okay, I have to look it up here and remember what it's called in schema.org. Data download is the type from schema.org, which you use to describe the packaged thing, right, the representation. Right. Okay, the distribution using DCAT terminology. Whereas data set is a conceptual thing. And data set in that sense can describe an unlimited thing, a feed, anything which it is useful to have a description of in a catalog or in any other place you want to have a description. So right from the beginning of DCAT, which was actually inherited by schema.org, which based its patterns on DCAT 0.9 or something back in the day, was breaking this nexus right at the beginning. And I wonder if that sort of conceptualization of it is still something which we haven't fully absorbed.
There's one back there.
Just on the OGC thing, no, in fact, in the direction the OGC has been moving in with the latest iterations of the standards there, it's actually quite straightforward to describe a service in its own right. So we've actually found that again, working pragmatically with what we're actually getting from a whole set of providers in Australia. The only problem we're having is the OGC shops that haven't moved to the latest standards and therefore can't so easily describe a service in its own right.
And
But
Adrian,
otherwise,
I'd like to talk with you later too, just to try and get at some of those examples that you've been doing at ARDC or in Australia, just so that we can have them as references for some of the work that we're doing as well then. Chuck, did you have something to say?
Yeah. So it wasn't just DCAT that schema.org kiped, right? So they also looked at GeoSparkle and kiped the spatial relations, but have not kept a walk with what the actual final sort of spatial relations and GeoSparkle standard was. So this is another sort of example where schema.org looked around for the best sort of fit for what they were trying to describe, took those did the right thing, took those authoritative resources and brought them in. But it's not clear how the process for updating these things, because these things, because they were taken from somewhere else, they evolved independently. And at some point in time, you want to resynchronize, right, between the two, right? And so that's, I think, an important discussion point with schema.org is, well, look, you took these things, these standards evolved independently, but now they would provide added value if you sort of reinterpreted what you've taken, given the fact that these things have evolved. So,
Alistair,
So it's just coming back to your thing about, in the context of OGC services, the value of it, and I think endorse what everyone else has said. This is hugely valuable, and it actually addresses some of the confounding problems I've had over the years of deploying OGC services and trying to work in contexts where things are discoverable. And it's that binding between either data describing an instance of a thing or data describing data sets and hooking in to the service infrastructure that supports either further actions against it or more discovery. And that's actually stopped projects in their tracks. Every now and again, we've come up with nice models for sort of coming up with little, meta services that help you index and discover things based on show me all locations that are measuring soil moisture in this catchment, and then where do I go from there? Right. So it's this is very exciting stuff.
So, and I mean, and based on that comment too, one of the things, especially as we kind of start nearing the end here, I think, do we end at 12? Okay. Everyone's out there going like, yes, we do. But I think one of the things I would like to start kind of thinking about and maybe just mention is the fact that, Adam and I actually have time that we can put in on this through the EarthCube project as well. So we will be working on this, and we will be doing some things on this. So, if you want to engage us in that, please do so, either through the GitHub, in person, or how, because we have some time to actually start trying to encode some of these things up, work with facilities to encode them, and do some test harvesting with the software that we have, and just try out some queries and see how these types of services described alongside the data sets can take place. And there's other work that's going on too. Ruth, Steve, and Ilya are involved in the resource discovery work that's inside EarthCube. Yeah. Right, right. So I mean, we would want to work closely with you guys, of course, obviously on that in terms of how we describe these and they become indexed and things like that. So, you know, whether through the GitHub repos, through the ESIP semantic committee, you know, with us directly, there's some time, some screen time that we can spend on this legitimately, and try out some of these examples. So please do that. So, Lewis.
I think it's maybe worth us considering as well current trends for how services are being designed, particularly Open API specification. I've seen efforts to produce, in particular, JSON-LD directly from an Open API spec.
Oh, right, okay.
And I just wonder, rather than trying to shove the data description, sorry, the service description into, you know, like data repository or data set, where that should just be an independent thing which is linked to from. And,
right,
you know, in that regard, I think if it's schema.org, which could be utilized to describe some of these things there, then we'd address what we need to over at schema.org, but we also recognize that potentially moving forward, more people will be using stuff like Open API specification. However, I mean, with that being said, I'm not ignorant of the fact that there's a whole bunch of services that are implemented. There's more services which are implemented not in schema in other frameworks. Right. And I think that that's where the use cases will come forward. But I think having one for Open API moving forward would be beneficial for us. Right,
and we're really cognizant of the fact that obviously there are descriptor documents, Open API Swagger, you know, even things like Waddle and get capabilities, things that we definitely don't want to recreate that work.
Yeah,
right,
yeah, absolutely.
And how best to leverage it, link to it, you know, is very much on our mind. But we also then, you know, have a functional goal that we want to try and get to as well, which is how do we have a data graph then that has sufficient context within it, no pun intended, that it facilitates the kind of, you know, fair, like, you know, discovery of these types of services and things like that, analogous to what we've already been able to demonstrate with type data set and things like that. So, but no, I mean, very good points, Lewis, that you know, you always are trepidatious about trying to reinvent the wheel. So, any other comments?
So some of the documents that Doug and Adam have been referencing here, the effort has been going on, for those that maybe don't know, to develop the recommendation from within ESIP for how we do this for data set and for data repository. And these extensions, or additions, I should say, I don't see them really as extensions. These additions are exactly where, you know, this effort, we want to drive this effort. Right. The purpose, I think, of it as well is converging on a submission of this to the ESIP program committee, similar to what's been done very recently with the data citations, revisiting data citations, updating them, and having that as an ESIP-wide accepted and endorsed effort. So I think that this here is prime time for us to come together and try and do something similar with this. That conversation mostly, I think, should be guided at the repository for, it's currently science on schema.org, but it's the geoschemas.org effort, which I think, you know, right, we may end up driving it towards. Right. So that's just more a larger contextual picture of where, you know, this is going to go from the ESIP point of view, hopefully.
Right, and I think, and Adam and I think are concur that like ESIP is the environment in which we want to have this discussion take place, and because it's a broader community, with lots of experience, and these types of things. So, you know, definitely, Lewis, we want to take advantage of, you know, the committee and other things in here to help drive this conversation forward and refine, you know, down how we would do these things. I mean, you know, what I'm really trying to, separate from ESIP, but in the EarthCube space and working with, you know, the resource discovery group as well, is like, how do we make recommendations within EarthCube of encoding patterns and publishing patterns for the data facilities to try and do some of these initial tests with. So, Peter?
So I know, of course, ESIP is not RDA, but I'm going to ask about the adoption question. And I think the anecdotal evidence of the dataset schema.org adoption is pretty evident. But that's based on knowing, who the possible candidates are. So for services, do you know, apart from the usual suspects, are we talking hundreds of institutions or organizations or projects? Are we talking 1,000? And if we are, and I'm talking about in this community, and if we are, those people need to see anything that, say, the STC puts together, like we put the citation stuff out there very, very widely because it's intended to really be representative of the community. So the question is now back to who knows how many, we sort of know how many data providers, but do we know how many data service providers there are?
Yeah, and I can't answer that. Ruth, you want?
I can't answer that question, but I was going to say that the Data Stewardship Committee and the Semantic Technologies Committee, and I think the Council of Data Facilities all think that this ought to be something that moves forward kind of regularly with telecons, like perhaps as a cluster. Mm-hmm. And the only issue with getting that going is that there needs to be volunteer leaders of such a cluster. And it can't be me and it can't be him. And so if there's anybody here who's sufficiently interested in this to want to organize that, I think we're looking for volunteers.
So could you describe that cluster again for me?
That cluster is basically the geoscience on schema.org cluster.
Oh, okay. Well, I think Adam should lead it.
That's fine by me.
Do I hear a second? There we go. We're done. Thanks, Adam. Appreciate that.
Good. Adam, I'll talk to you shortly about how to get
You thought I was joking, didn't you?
No, I know y'all are joking.
Ted, in the back.
One of the use cases that like Blodgett and some other guys really made look good with various OGC services and also ISO metadata related stuff was sort of the back end. And I'm sitting back here listening, and it's sort of a use case genre that I haven't heard discussed much, but is anybody sort of using schema.org or, services in the back end that could be, sort of internal utilization of service descriptions and data that's provided by services sort of behind the scenes, behind an externally facing user interface. And that was I thought that a few years ago Dave made some really solid points about that's a rich environment for doing this kind of stuff, because you're dealing more with systems and less with users. Is anybody working in that realm?
Right now, I mean, that's essentially what's happened at the Earth Data client, search client, is all service to service. So, okay, it's based upon what the user puts in, but they never end up knowing that anything's going on. It's totally opaque. And it's not just that Earth centralized metadata catalog out to whatever. It's also happening, it'll be happening from wherever to back to the centralized catalog. I think there's nuances between getting that right, which we've encountered as more of the systems which actually do the lifting. like the handoff, but it's been referred to, the terminology for that is just kind of smart handoff. It's using the context from one system without re-entering it at the other system over here. And this has all been facilitated through in schema.org's search action. I don't think search action does really correctly describe what is going to be happening over at the target system, because it might not be a search for start. It might be something other than a search. But there's a lot of that going on just now, Ted, yeah. And there's a lot of examples of that, particularly what's happening at the Earth Data Search client. And there's no reason that it couldn't be any OGC, it couldn't feed into any OGC, you know, like a web feature service or a coverage service or something like that. There would be no, there's nothing specific about those that wouldn't let them tie into this interest, into the mechanism for.
All right, thanks. So we've reached the top of the hour. So just a few, just last quick things. One, thank you very much for the discussion. It's incredibly helpful. And it's really just one, I know Adam and I are just very appreciative to be part of this community and the discussions that we can have. After lunch, you can just come right back here and spend the whole day in ballroom A, right, for 2 more sessions on this. And then also, Adam wanted me to point out there's an AGU session that has schema.org topic with regards to tooling and things like that. Your abstracts are due by July 31st, so work on those over the lunch. So, all right, everyone, thank you very much. I really appreciate it.